Liftoff. The perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Successfully launching and traveling through space. That's challenging, but not nearly as difficult as landing the Perseverance rover in what has become NASA's most ambitious mission to Mars. Launched in July 2020, Perseverance is the newest generation Mars rover. It's high-tech, NASA's most sophisticated rover ever built, and it's the biggest to land on the Red Planet. Perseverance is the first part of a multi-billion-dollar effort to bring Martian rock samples back to Earth. Scientists are looking for ancient life on Mars. The countdown to the February 18th landing is excitement mixed with high anxiety because NASA scientists say it's the most critical and most dangerous part of the mission. Entering the Martian atmosphere at more than 12,000 miles an hour, Perseverance will streak across the sky like a meteor for 7 minutes before finally touching down. NASA scientists are calling the sequence of landing maneuvers the 7 minutes of terror.
Because it's all done automatically. So you come in through the atmosphere at miles per second and use an aero shield and a parachute and then the sky crane to land wheels first. And there's a cable that comes down about 30 yards with the sky crane, this rocket thing, kind of suspended. And the cables are cut automatically and the sky crane goes off. And then you've got a rover on the surface. That's the most difficult part.
If anyone in St. Louis knows about this nail-biting descent, it's Ray Arvidson. The Washington University in St. Louis professor played a significant role in several rover and lander launches and landings. He's deputy principal investigator for the highly successful Mars exploration rovers Spirit and Opportunity. He's currently a NASA science team member for the Curiosity rover in charge of path planning, and he is the director of the NASA Planetary Data System Geosciences Node. This means his campus facility will be archiving all the Perseverance data.
All their data products, images, chemistry, mineralogy, organic content, posted through our websites. Everybody's going to be coming to us to figure out what the context was for all the observations.
But landing on Mars comes first. Arvidson even helped choose the landing site for Perseverance,
which is Jezero Crater with this big eroded delta. And we're continuing to provide images and other pieces of information that help the science team, once they land and start traversing, where to go to get the best samples.
Once safely on the surface, Perseverance and its science team will search for signs of ancient life and collect samples to be returned to Earth. Arvidson is part of the team that created those specifications.
So we've been trying to get, that is the community, arguing with NASA and Congress and the president all the way back to the 1970s to return samples to Earth. So the whole idea is to go to a place, drill and get the samples, put them out on the surface to be returned by a later mission. Why is it so important? Because you can do many, many, many more very detailed analyses in the laboratory than you can do from a rover.
Over the years, Arvidson, fellow scientists, and rovers experienced many milestones, finding evidence that Mars once had fresh water and signs of microbial life. Now Perseverance is sent to accomplish even more. Even the name Perseverance is fitting for the role Arvidson has played.
Partly because it took so long to get this mission, so there was Perseverance.
How do you like the name?
I like the name, except, Opportunity, which was the rover I was the deputy principal investigator for, wound up sitting on Perseverance Valley. What's the last time we heard from it? After a huge dust storm in June 2018, but that's okay. They can have the name for the mission, but I always remember Perseverance as the last place that our Opportunity rover traversed.
Which carries some sadness. For all Arvidson has done and will do, so much is on the line the moment Perseverance enters the Martian atmosphere.
This is a mission that I've been pushing for since the 70s, and it's the first step in getting really characterized samples from known geological environments back on Earth. So I really want to see it succeed.